There we go, straight onto it. So here we have. Now this is quite nice because this, I think, is a good example of one of those improper integrals that leads you through a really rigorous step-by-step method for doing it. Notice again, we've got the kind of question that is a part A and a part B. B is split up, but these two things are unconnected. So if we do part A first, and then we kind of move away from that. Now, we're not actually that surprised by this. We know, when we talked yesterday about Core 1, we know that when we do differentiation stuff in Core 1, quite often, part of what they're asking for us to do is to deal with some algebra first, to rearrange something, to tidy something up, so that you've got it in a nice format to differentiate or integrate it. And we've got the same thing happening here. We can't dive straight in. It's really important that we don't just integrate top and bottom of this, because it doesn't work like that. We need to get it so that we can see it one term at a time, just on their own, before we do anything else. So here we've got a fraction that is over a common denominator. So we can split up the fraction and think about it in two parts. This is x cubed over x plus 3x to the half of x. It's really important that we recognise that we can't just dive in with these things. We've got to split them up. We've got to have them in that nice format of something x to the n so that we can work with it. So this becomes, what have we ended up with? X cubed over x. Subtracting the powers, that just gives us x squared. And here we've got 3, well the 3's alright. And then we're doing x to the half divided by x. We subtract the powers. So a half take away 1 gives us x to the minus a half. Right. Now it's important, isn't it? I think that might have been John phoning up just to complain that I was trying to push the cast diagram on people from earlier. Okay, so we've got this to integrate now. We've not done any integration. It's a big integration question. We've done quite a lot of work but never integrated. So, we're going to add 1 to the power and divide by the new power, giving x cubed over 3. Now let's be really careful. We talked yesterday about the dangers of kind of minus numbers and getting confused with that. We've got fractions going on here as well. Add 1 to the power gives us 3x to the half, and we're dividing by that new power. So we're dividing by a half, and we're going to write plus c because we've got no limits and we're integrating. Right, we're nearly done. I'm happy with x cubed over 3. Oh, I've written 3. X cubed over 3. We should know this by now, shouldn't we? But if we divide by a fraction, it's the same as multiplying by the reciprocal of that fraction. So dividing by a half is like multiplying by a half flipped upside down. So multiplying by 2 over 1. So we get 6x to the half plus c. Are we happy about this? We know that if we divide anything by a half, that equals 2 over 1, which we're just going to write as 2. We've got 2 times 3, x to the half. Great. Right, let's go on to part B, which is a bit more interesting than this. Now, part B said, find, in terms of a, the value of the integral from 2 to a of 6x to the minus 4, where a is a constant greater than 2. It has to be greater than 2, otherwise that bit there has kind of problems. So what we're going to get is the integral from 2 to a of 6x to the minus 4 dx. Is that right? Or have I just copied it down? That's right. Okay. And we're going to find this in terms of a. Kindly, they've already written it in the format that we need it to integrate. It's already there straight away. So if we go into this now, carefully work our way through. Add 1 to the power and divide by the new power. So we've got 6x to the minus 3 over minus 3 between 2 and a. We're then going to substitute things in. Well, actually, maybe let's tidy this up first, because this is, well, how much can I do with this? This is 6 divided by minus 3, which is minus 2. But we've also got x to the minus 3 here. Now, I think when I'm subbing my limits in, I'd quite like to have that without the negative power. X to the minus 3 means 1 over x cubed. So I actually think I want to write it like that. So it's minus 2 over x cubed. Now I'd like to put the limits in. So this means minus 2 over a cubed minus 2 over 2 cubed. And I want to make this as neat as I can. It didn't specify any details about how they wanted it given. But we've got minus 2 over a cubed, and look, this is plus, because it's minus minus a quarter. That would end up being 2 over 8, which is a quarter. And that's enough for our answer, but I'm going to write a quarter minus 2 over a cubed. That's my answer then. Now, I'm not entirely sure how others would have done this, but with my group, when we did questions like this here, which we call an improper integral, the integral from 2 to infinity of 6x to the minus 4, I suggested that we don't work with infinity in that. Instead of infinity there, we write another letter. We often use k, but we can use any letter we like, maybe a. And that's exactly what they've done here. They've told us to solve this expression by working between 2 and a constant, 2 and a number, and then thinking about what happens as we approach infinity. So that integral that we're left with, 2 to infinity of 6x to the minus 4, that's saying what happens to this now as a gets closer to infinity. And we know that as a approaches infinity, the only bit that's got a in it is 2 divided by a cubed. Now, if a is a reasonably big number, say if a is 100, 2 divided by a cubed is a very, very tiny number, isn't it? 100 cubed is massive, and 2 divided by that would be really tiny. The bigger that a gets, the closer 2 over a cubed gets to 0. So as a approaches infinity, 2 over a cubed approaches 0. From which we can be confident that the integral from 2 to infinity of 6x to the minus 4 dx is equal to, well, we're left with a quarter take away 0. And a quarter take away 0, the last time I checked, was equal to a quarter. So that's going to be our answer. Does that make sense as a final kind of step to that? We did one of these in your mock exam that was similar, but was as hard an example of this as I've ever seen, because they really messed with that. They gave you different values and asked you to work out something else from it. And that was really unkind. But that's a much more standard type of that sort of integral. They're quite nice, aren't they? There we go. And that's maths.